students, good morning. This class is for the students of Inter Math. The medium is English. This class is for the board exam, and after completion of board exam, critical problems will be discussed. For competitive exams like IIT, JEE Main Advanced, NDA and others. In this video, I will discuss more important problems of the chapter limit calculus. Let us see question number 5. Here we see that at x equal to 0, the function takes the form of 0 by 0. We will simplify this function so that it becomes in the form of formula which I have discussed in before video, and we are able to use the formula directly when this function comes in the form of, when this function converts into form of formula which I have already discussed in previous video, then we use directly the formula and get the limiting value of the function. Let us see. At x is equal to 0, the function takes the form zero by 0. Now limit x tends to 0, tan x minus sin x by x cube. This is equal to limit x tends to 0, sin x by cos x minus sin x by x cube. This is equal to, we are going in that step that this function converts into the form of appropriate form, and we use the formula directly. See, limit x tends to 0, sin x minus sin x into cos x by x cube, cos x is equal to limit x tends to 0. Here we take out sin x common as common factors are taken out. We take common sin x here. Sin x into 1 minus cos x by x cube into cos x. Now here we use trigonometrical formula, as we know that 1 minus cos 2x is equal to 2 square sin x. Here 1 minus cos x is, then this will become 2 sin square x by 2. This is equal to sin x into 2 sin square x by 2 by x cube into cos x this is equal to limit x tends to 0. Now here sin x and cos x, sin x by cos x becomes tan x and x cube. Here x square is, so x cube we factorize it into x and x square. Sin x by cos x will become tan x and take here x tan x by x, and also sin square x by 2, this will be x square by 4 and a square x by 2 whole square. We divide or multiply by same quantity, that and this process help us to obtain the appropriate destination. This is called mathematical tricks. Now let us see. I write it here above. And you may write it below here also. This is equal to, see, in this side, limit, here, no, we write it above. Limit x tends to 0, tan x by x into sin x by 2 by x by 2 whole square. Where you have multiply the denominator by 1 by 2, so you will multiply also the numerator. This is equal to into 1 by 2 square. Here 1 by 2, yeah, or you can also say it, we have divided here by 1 by 2. We also multiply by 1 by 2 whole square. Here we have divided by 1 by 2 square. And so we multiply 1 by 2 square also, so that no change takes place in the function, and we have arranged the function into the form of trigonometric formula, and we will be able to use formula directly. Let us see. You note it in your notebook. I write next step after this. Okay. This is equal to, from here, this is equal to limit x tends to 0, tan x by x, apply limit in both, into limit x tends to 0, sin x by 2 by x by 2 square into 1 by 2 whole square. This is equal to 1 into 1 square. Here 2. 2 into 1 square into 1 by whole. 2. This is equal to 1 by 2. This is the required limiting value of the function. You note it in your notebook. Question number 6. Evaluate limit x tends to 0, 1 minus cos 2x by x square. Here we see that at x equal to 0, the function takes the form 0 by 0. Here we also move in that way that we are able to convert it into the formula. Into this, we are able to convert and in the trigonometrical formula, so that we are able to use the formula directly. Here we also use trigonometrical formula. From trigonometry, we know that 1 minus cos 2x is equal to 2 sin square x. Here, sorry, and it's not 2, there is k. So this will become 2 sin square kx by 2. At x equal to 0, the function takes the form 0 by 0. Now, limit x tends to 0, 1 minus cos kx by x square. This is equal to limit x tends to 0 to sin square kx by 2 by x square. Here we also multiply denominator by, here we also divide the function by 1 by 2 square. Then we will multiply by 1 by 2 here we divide the function by k by 2 square. So we also multiply the function k by 2 square, so that the function does not change, and we get the path. To convert the function into the trigonometrical formula which I have discussed in previous video. Let us see. This is equal to limit x tends to 0 to sin kx by 2 by kx by 2 whole square. See here, we have divide the function by 1 by 2 square, k by 2 square, k by 2 whole square. So we multiply here also k by 2 whole square. Now the function has come in appropriate form. This is equal to 2 into limit x tends to 0 sin kx by 2 by kx by 2 whole square into k square by 4. This is equal to 2 into 1 chi square into k square by 4 this is equal to k square by 2. This is the required limiting value of this function. K square by 2, here 2 is k square by 2. This is the required limiting value of the function. You note it in your notebook. Back करो तो. Next question. Question number 7. Limit x tends to alpha, x sin alpha minus alpha sin x by x minus alpha. Here we see that at x equal to alpha, the function takes the form of 0 by 0. Here, at x equal to alpha, but alpha is not 0, then in this case, we use the formula. See here formula. Limit x tends to a, fx is equal to limit f a plus h tends to 0. Here, if alpha is not 0, x tends to alpha. X is equal to alpha, but alpha is not 0. Then we use this formula in this situation. Let us see. At x is equal to 0, the function takes the form 0 by 0. But if x equal to alpha and alpha is not 0, then we use the formula limit x tends to a, fx is equal to limit h tends to 0, f a plus h. I have discussed the formula in previous video. Now, limit x tends to alpha, we put x equal to alpha plus h. Then what will occur? H tends to 0. When x tends to alpha. See here, when x tends to alpha, h tends to 0. Now, limit x tends to x tends to alpha. X tends to alpha, x sin alpha minus alpha sin x by x minus alpha. This is equal to, I write it, next step here. This is equal to limit h tends to 0, alpha plus h, sin alpha minus alpha sin x, alpha sin alpha plus h, alpha sin alpha plus h, alpha plus h by h. Now alpha sin alpha, from alpha sin alpha and minus sin alpha plus h, we take common alpha. We take common alpha. Alpha sin alpha and minus alpha sin alpha plus h. We take alpha common. Let us see. This is equal to limit h tends to 0, alpha sin alpha minus sin alpha plus h, plus h sin alpha plus h sin alpha by h. Now here we also use trigonometrical formula. From trigonometry we know that sin c minus sin d is equal to 2 into cos c plus d into sin c cos c plus d by 2 into sin c minus d by 2. We use this formula here. This is equal to limit h tends to 0, alpha into 2 cos alpha plus h into sin by 2 sin alpha minus alpha plus h plus h sin alpha by h. Here we have used the formula sin c minus sin d is equal to sin cos c plus d by 2 into sin c minus d by 2 d by 2 plus h sin alpha, this here. This is equal to limit h tends to 0, alpha into cos alpha plus h by 2 into sin minus h by 2 plus h sin alpha by h. Limit will here come here. Limit will is this limit here. H tends to 0. I have also write it again here. I have also written it here to remove the confusion, my dear students. Now you note it in your notebook. I write then next step. Is equal to 2 into limit h tends to 0, alpha cos alpha plus h by 2 into minus sine h by 2 by h by 2 here. H has come here with this sine h by 2, and we have divide the function by 1 by 2, so we also multiply the function by 1 by 2 plus sine alpha. H has removed, h by h cancel, h by h cancel. Here is in this here h come with this. Here I have divide the function by 1 by 2. We multiply the function by 1 by 2. This is equal to, now the function has been arranged in the formula form. Now we direct use we write one step also. 2 into alpha limit x tends to 0 cos alpha plus h by 2 into minus limit x tends to 0 sine h by 2 by h by 2 into 1 by 2 plus sine alpha. Now use the formula. This is equal to 2 into alpha cos alpha into minus 1 into 1 by 2 plus sine alpha. This is equal to minus alpha cos alpha, 2 cancel, plus sine alpha. This is equal to alpha minus alpha, this is equal to sine alpha minus alpha cos alpha. We have dealt the question one by one. We have dealt the question step by step, so that you should develop your basic concept. When critical problems will be discussed for competition, then tricky method will be discussed, which will be used in competitive exams. Here I have dealt extensively to develop your basic concept. This is the required limiting value of the function. You note it in your notebook. Next problem, question number 8. Here we see that at x equal to infinity, the function takes the form 1 to the power infinity. I have already told you in previous video, in this situation, we use logarithm first, and then we obtain the limiting value of the function. Let us see. At x equal to infinity, the function takes the form 1 to the power infinity. In this situation we use logarithm. Let y equal to 1 plus 1 by x to the power x. Now taking log on both the sides, let assume the function as y. Let y equal to 1 plus 1 by x to the power x. Now we take log on both the sides. Now taking log on both the sides, on both the sides, log y is equal to log 1 plus 1 by x to the power x, or log y is equal to x log 1 plus 1 by x. Now we expand the formula using logarithmic series, which I have discussed before. We have already read in algebra. Now we expand it. You note it in your notebook, then I will write next step. Log y is equal to x (1 by x minus 1 by 2, 1 by x square plus 1 by 3, 1 by x whole cube, minus and so on, or now apply limit on both sides. On expanding expansion by logarithmic series. Logarithmic series. Now apply log on both. Now apply limit on both the sides. Limit x tends to infinity, log y is equal to limit x tends to infinity 1 minus half 1 by x plus 1 by 3, 1 by x square minus and so on, or log limit x tends to infinity y is equal to 1, or limit x tends to infinity, this is equal to e to the power 1. As we know from log ex is equal to 1, then x is equal to e to the power 1. maybe we can write log ex equal to a, then x equal to e to the power a. Here 1 exists, then we have written e to the power 1. From log to log, we have already known this from log. Log limit y is equal to this, or limit x tends to infinity, this 1 plus 1 by x to the power x is equal to e. This is the required solution of this function. This is the required limiting value of the function. We have discussed the problems step by step to develop your basic concept. When critical problem you discuss for competition, then tricky method will be discussed. You write it in your notebook. In next video, I will also discuss more problems of the chapter limit calculus. Please like, share and subscribe my YouTube channel Mathematics Vibes. I Satish Kumar Thakur, lecturer in math, Rajaram Shah College, Raxaul, Bihar, India. Have a nice day. Thank you.